death. It's a topic that has fascinated and frightened humanity since the dawn of time. It's the ultimate unknown, the one certainty in life that we all must face. But what really happens when the human body stops working? What transforms a living, breathing person into an inert vessel? While shrouded in mystery and often met with apprehension, the process of death is a fascinating biological event. It's a complex cascade of events that unfolds at both the macroscopic and microscopic levels. Understanding this process can be insightful, offering closure and even a sense of peace. This essay will explore the science behind what happens when the human body ceases to function. We'll journey from the moment of death, exploring the cessation of vital organs, to the intricate processes of cellular death and decomposition. Join me as we delve into the science of death, unraveling its mysteries and fostering a deeper understanding of this inevitable stage of life. The heart, the tireless engine of our bodies, beats ceaselessly throughout our lives, circulating blood and sustaining every cell. Death, however, marks the end of its tireless efforts. When the heart stops beating, the transport of oxygen and nutrients to the body's tissues and organs ceases. Without a constant supply of oxygen, cells begin to die. The brain, highly sensitive to oxygen deprivation, is among the first organs to succumb. Within minutes, brain cells begin to die, leading to irreversible damage. This loss of brain function is what defines clinical death, the point at which vital functions like heartbeat and breathing have ceased, and resuscitation is no longer possible. The brain, the seat of consciousness, thought, and memory, is perhaps the most mysterious organ in the human body. Its cessation is what we most associate with death, the loss of personhood, of the essence of who we are. When the heart stops and blood flow to the brain is interrupted, the intricate network of neurons that fire ceaselessly to create our thoughts, emotions, and memories falls silent. This loss of brain activity marks the irreversible end of consciousness. While there have been anecdotal accounts of near-death experiences, scientific evidence suggests that these are likely the result of the brain's last bursts of activity as it shuts down. Once brain death has occurred, there is no coming back. While the cessation of heartbeat and brain activity mark the clinical definition of death, life continues at the cellular level for a short period. Individual cells, each a tiny factory of life, possess varying degrees of resilience to the lack of oxygen and nutrients. Skin cells, for example, can survive for several hours after the heart has stopped. Muscle cells, on the other hand, are more sensitive and begin to die within a few hours. Brain cells, as we've seen, are among the most vulnerable, succumbing to oxygen deprivation within minutes. This staggered death of cells is why organ transplantation is possible. If organs are harvested and cooled soon after death, their cells can remain viable for a time, allowing them to be transplanted into a recipient's body. Section 5. Rigor mortis, the stiffness of death. Several hours after death, a curious phenomenon occurs. The body begins to stiffen. This stiffening, known as rigor mortis, is caused by a biochemical reaction within muscle cells. In life, muscle cells contract and relax due to the interaction of two proteins, actin and myosin. This interaction is regulated by adenosine triphosphate, or ATP, the energy currency of cells. After death, ATP production ceases, and without it, the actin and myosin filaments become locked in place, causing the muscles to stiffen. Rigor mortis typically begins in the smaller muscles of the face and jaw, spreading to the rest of the body over several hours. It reaches its peak at around 12 to 24 hours after death, after which it gradually subsides as the muscle fibers break down. Section 6. Decomposition, nature's recycling process. Death, while marking the end of a human life, is also a beginning. The beginning of decomposition, a natural process by which the body is broken down and its components recycled back into the environment. Decomposition is driven by a complex interplay of internal and external factors, including the body's own enzymes, bacteria, fungi, and insects. These agents of decay work in concert to break down the body's tissues, organs, and bones, ultimately reducing them to simpler compounds. This process, while often perceived as gruesome, is essential for the recycling of nutrients in the ecosystem. The breakdown of organic matter provides nourishment for plants and other organisms, ensuring the continuation of life. Section 7. Stages of decomposition. Decomposition is not a single event but rather a continuous process that unfolds in several stages. These stages, while variable depending on environmental conditions, follow a general pattern. Initial decay. This stage, lasting from a few hours to several days, is characterized by the breakdown of soft tissues by the body's own enzymes, a process known as autolysis. Bacteria in the gut, now unrestrained by the immune system, begin to proliferate and contribute to the decomposition process. Putrefaction. This stage, marked by a strong, unpleasant odor, is driven by the activity of bacteria, which release gases like methane, hydrogen sulfide, and ammonia. The body may bloat and discolor as these gases accumulate. Black putrefaction. In this stage, the soft tissues begin to liquefy, and the body collapses as gases escape. The odor intensifies, and the area surrounding the body may show signs of contamination from the decomposition fluids. Butyric fermentation. As decomposition progresses, the environment becomes less hospitable to bacteria, and fungi begin to dominate. This stage is characterized by the conversion of fats into butyric acid, which gives off a rancid, cheesy odor. Dry decay. In the final stage of decomposition, most of the soft tissues have been broken down, leaving behind bones, hair, and other resistant materials. These remnants will slowly decompose over time, eventually returning their nutrients to the soil. Section 8. Legal and social implications. Death, while a biological certainty, also carries significant legal and social implications. The declaration of death, the handling of human remains, and the rituals surrounding death are all deeply ingrained in human societies and vary widely across cultures. In most societies, death must be certified by a medical professional, and the cause of death determined. This information is essential for legal purposes, such as inheritance, insurance claims, and criminal investigations. The handling of human remains is also subject to legal and cultural norms. Burial, cremation, and mummification are just a few of the ways in which humans have disposed of their dead throughout history. Rituals surrounding death, such as funerals, wakes, and memorial services, provide a way for the living to grieve, celebrate the life of the deceased, and find closure. These rituals vary greatly across cultures, reflecting different beliefs about death and the afterlife. Section 9. Death, a natural part of life. Death, while often feared and misunderstood, is an inevitable part of life. It's the natural conclusion to the human experience, the final chapter in our individual stories. By understanding the biological processes that occur after death, we can approach this finality with less fear and more acceptance. While the cessation of our physical bodies marks the end of our conscious existence, it also triggers the beginning of a new cycle, a return to the elements from which we came. In death, as in life, we are part of a larger interconnected web, our individual journeys woven into the fabric of existence. So, as we navigate the complexities of life, let us remember that death, while marking an end, also signifies a beginning. It's a reminder of our interconnectedness, our shared humanity, and the preciousness of the time we have.